let's move to a special attribute in forest and sustainable forest management, looking at habitat trees, exploring the potentiality of ALS to detect habitat trees. Thank you, Giovanni.
Yes, thank you. Good morning to everybody. I am Giovanni Santopuoli from University of Molise. As most of the authors in the list, except Professor Bazzi, which is here, and he's from Oben, an academic spin-off that later I will show you which are our tasks. So I will show you the work focused on the assessment of forest biodiversity, considering the habitat trees, or I will show you that we consider the micro-habitats which are present on the trees. Assessment of forest biodiversity. I want to say that forest biodiversity is not only related to the amount of tree species in the forest, but also it considers a lot of living organisms, life forms, which can be found in the forest. So we have to move our activities from monitoring the forest structure to tree structure. And it is a challenging task, time-consuming task, and this is the reason because we want to use airborne laser scanner data for detection these microhabitat and at least habitat trees. So this is the aim of this work. There are several indicators for monitoring forest biodiversity. There is the set developed by Forest Europe process. Over the years, it is already under revision for some modification, but tree-related microhabitats are not considered for this set of indicators, even if the interest on these topics is increasing in the last decade. And several authors consider this structure, this particular structure, very important for enrich the biodiversity in the forest. The study area is the Pennataro Forest. It is one of the three study sites of the Fresh Life project. It is in the Molise region. The Molise region is the owner of this forest, and this forest plays a significant role both cultural and ecological for our region because it is a regional forest, it is part of the Natura 2000 site, and since a few years ago it has been recognized as a core area of a new Man and Biosphere Reserve. Collemeluccio Monte di Mezzo, Alto Molise is the name of this Man and Biosphere Reserve. This is the sampling plot. According to the project Fresh Life protocol, the forest, which is at almost 200 hectares large, was divided in a small pixel with 500 square meters. Then this pixel, as my colleague presented in the last presentation, was clustered in 50 clusters, and then one cell of these 50 clusters was selected for collecting data. Forest inventory data. Yes, it is. Yes, the ecological role of the forest because there are more than 10 tree species. It is a mixed forest and a multi-layered forest with several styles of forest. Forest inventory considered tree diameter, tree height, length of the crown surface, of course vitality or tree health, but also the position of the trees. Why the position? Because the position is important since the main aim of the project Fresh Life is to demonstrate how remote-centric techniques can be useful to assess sustainable forest management. And so the position of the trees to correlate with remote sensing is very important. We used this particular tools, it is called the field map, that allow to georeference each trees or each object that you found in the forest. So the tools, this field map, allow to generate automatically a shape file, and you can add information that you want. In our case, we add information about the classification of tree-related microhabitats. For the observation of the tree-related microhabitats, we used the classification developed by Winter and Moyle in 2008. They consider more than 20. In the last presentation, we saw 23 microhabitats, because there are 3 microhabitats that I didn't report here because they are related to the deadwood. I forgot to say that we focalize our attention to the living trees. So monitoring tree-related microhabitats for us is important, because when you find microhabitats on trees, you can say that that trees is a habitat trees. So often habitat trees are the largest trees that you find in the forest, and the largest trees are also the most interesting trees for timber production. So monitoring microhabitats is important to balance this conflictual function, production and biodiversity conservation. So this is the reason why we concentrated on the living trees. As concerns the LiDAR data, the Oben was responsible for this task. He provided the crude point of airborne laser scanner using the yellow scan LiDAR sensor. The LiDAR was mounted on the ultralight helicopter. The flight was around 70 meters above canopy. So, but Professor Balsi will show you in the next presentation. This is the approach. We didn't use random forest. We use a generalized linear model. So we took the forest inventory attributes. We took the 38 ALS metrics extracted with last tools, with last canopy, and we launched the generalized linear model. Before to implement the model, we made a filter. We exclude from this operation the variables, the metrics, which present an autocorrelation value. So the threshold was 0.5. Then, to exclude these metrics, we performed this model with a stepwise AAC for the selection of the variables. We implemented 2 alternative methods, Poisson and the negative binomial for count data distribution, and also then we identified the outliers which were present in our data set, and we performed again the generalized linear model with and without outliers. At the end, I will show you the R value and the RMSA value. Then I will show you the thematic map that we produced about habitat trees, about abundance of tree-related microhabitats, about single microhabitats. And then also we made the cross-validation applying the Li1-out methods. So this is just to show you the forest structure in summary. I want to focalize my attention on this histogram, which shows that not only the microhabitats were found in the forest. There are several microhabitats with a low value of frequency, and this is the reason why we can apply the model only to the most frequent microhabitats. These are our results. I said we performed 4 alternative models, and in most of the cases, the negative binomial without outliers resulted the best model to predict our variables. There are some exceptions, like this, the microhabitat named M4, which regards the damage in the crown. But I will show you later. And these are the, yes, the main result. The variability of three related microhabitats, this variable, finite because for us it's rather normal, because it is difficult to detect a different kind of microhabitats starting from the cloud point. So it is difficult to distinguish between a cavity on the trunk and the cavity on the branch, for example, or a different type of edifice present on the trunk. So, but the results are rather interesting. And these are the maps that we produced. This is about the microhabitats M12C, cavity after hollow branch. This for M7. This is for the number of habitat trees. This is for the abundance of tree-related microhabitats. And M4 and M12E. I put the order of the maps are based on the quality of the data produced, quality of the map. So, in conclusion, we can say that it is possible to use airborne laser scanner to detect habitat trees, so to assess forest biodiversity. There are some weaknesses that are still present, so we need to improve our study, our efforts to identify new approach or to integrate ALS with terrestrial laser scanning, for example, or RGB camera for better detection the microhabitats. But the main conclusion is that it is possible to use LiDAR data to assess forest biodiversity. Further information, during the implementation of the Fresh Life project, we implemented a plot of 1 hectare of surface, 1 hectare large, within which we mapped all the trees, and also we observed the microhabitats. This is a martelloscope site, and it is part of the European network of martelloscope sites. The main aim of this work was to assess the economical and habitat value of each tree. And for future perspective, we want to assess the spatial distribution of microhabitats and of tree habitats in order to improve the evaluation of the habitat quality, habitat value. So, thank you.
Thank you, Giovanni. Some more road to do, but I think that the way forward is correct. It is very important to look at single trees for sustainable forest management and several rules at regional level, for example, in Italy, that gives mandatory obligations to harvesting people to leave some trees in the forest, and we have to choose the trees. This could be a system, for example, in management. But of course, some more studies are needed. There is time for 1 or 2 questions, if any. Okay, otherwise, thank you very much.